Hello my dear students, welcome you all for the Samveda e-learning program. We are discussing about chapter number 13, exponents and powers. Today is the second session. You are going to learn more about exponents and powers in this session. Before going to learn about today's session, let us recall what we have discussed in the first session. In the first session, you have all learnt about exponents, the meaning of exponents, power and base of an exponent. And also, you have learnt about the method of reading an exponent. And also, we have converted number into exponential form. Similarly, we have converted exponent to a number. So, these are the important things we have discussed in the first session. Exponent means it is the shortest form of expressing large numbers or very large numbers. So, if you think about 10,000 means, the 10,000 can be expressed in a simplest form as 10 to the power of 4, because to obtain 10,000, we should multiply 10 by 4 times, that is 10 into 10 into 10 into 10. So, 10 is repeated 4 times, that is why it can be expressed as 10 to the power of 4 or 10 raised to the power of 4. In case of an exponent, there will be a base and exponent. The 10 is called as base in this case, and the number 4 is called as exponent. So, which is the base over here? Here 10 is the base and 4 is the exponent. Similarly, if there is a to the power of n means, a is called the base and n is called the exponent. So, these are what we have discussed in the first session, and also we have discussed about method of reading an exponent. An exponent is going to be read in a specified manner. 10 to the power of 4 is read as 10 raised to the power of 4 or 4th power of 10. So, this is the method of reading an exponent, and also we have found the value of an exponent. So, 2 to the power of 5 means, so 2 has to be multiplied 5 times, it has to be multiplied 5 times. So, if you are going to multiply 5 times means we will get 32. So, therefore, 2 to the power of 5 yields 32. It is the value of this 2 to the power of 5. What about the value of 2 to the power of 2 or 2 squared? It is 4. What about 2 cubed? It is 8. So, like this we are going to find the value of the exponent. Similarly, we come to know that with an example, minus 1 to the odd power is always yield minus 1, and minus 1 to the even power will always yield plus 1. So, based on this, so we have solved few problems. In all the cases, if there is a odd power like this, minus 1 to the power of 3 is gives rise to, or which yields minus 1. Similarly, minus 1 to the power of 4 gives us plus 1. Let us come to the today's important concept. In this class, you are going to learn about multiplying powers with the same base, dividing power with the same exponent, and also you are going to learn about number with exponent 0. So, these are also called as the laws of exponents. Let us learn one by one. Are you ready with the book and pen? My dear student, multiplying power with same base which gives a unique answer. Let us learn through an example. In case of 2 squared and 2 cubed, whenever we are going to expand this 2 squared and 2 cubed, we will get like this. 2 squared means the 2 is repeated twice, 2 into 2. 2 cubed means 2 is repeated 3 times. Therefore, when we are going to multiply this, we will get 2 into 2 into 2 into 2 into 2. That means, so here among the product of 2 cube and 2 squared, we will get the repetition of the number 2 in 5 times, that can be written as 2 to the power of 5. So, we will get, or we get 2 to the power of 5 through adding the powers. This 2 as well as 3, the sum of these 2 and 3 gives us 5. So, therefore, we can come to the conclusion that, so whenever the exponent having same base and having different power, the product will gives us the sum of the power of the exponent. So, that is in this example 2 square into 2 cube gives us 2 to the power of 5. So, that means here that in 2 square and 2 cube the base is same, the sum of the exponent, that is 2 and 3 is 5. So, let us go with another example by taking the negative value. Here in this case minus 3 to the power of 4 into minus 3 cubed. In these two cases, so if you are going to expand minus 3 to the power of 4 means we will get minus 3 into minus 3 into minus 3 into minus 3 into minus 3 cubed means we will get minus 3 into minus 3 into minus 3. So, if you are going to combine these two things, we will get the minus 3 is multiplied 7 times. So, that can be expressed in simplified form as minus 3 to the power of 7. That is equivalent to minus 3 to the power of 7 is also equivalent to 4 plus 3. So, what about that 4 and 3? 4 and 3 are the exponents of the two exponents having same base. So, that gives the answer. Again note that the base is same and the sum of the exponent is 4 and 3, which gives us 7. Let us take another example, a square and a to the power of 4. The product of these two gives us what? So, a square means the a should be multiplied 2 times, a into a, and a to the power of 4 gives us a into a into a into a. So, if we are going to combine these two things means we will get a to the power of 6, which is equivalent to a to the power of 2 plus 4. So, in this case also the base is same and the sum of the exponent 2 plus 4 gives us 6. In case of 4 square and 4 square, which gives us 4 to the power of 4, that means we have to add the exponent here, 2 plus 2 gives 4. In case of 3 square and 3 cube, the exponents are 2 and 3, so we have to add them. So, finally, we will get 3 to the power of 5. From the above examples, what we can conclude that if there is a exponents having same base and having different power, which is equal to the product of the two exponents with the same base and with the different power gives us to, or which is equal to a to the power of m plus n. So, we have to express with the same base, but we have to add the exponents, or what we can conclude the above examples. If the two exponents having same base with the different powers, which is equal to the base and to the power of the sum of the exponents, that is m plus n. This is what we call the law of exponent. So, let us solve few problems by using the law of exponent. A to the power of m plus a to the power of n is equal to a to the power of m plus n. Using law of exponents, simplify 2 cubed into 2 to the power of 5. Here we have to use the law of exponent, that is a to the power of m into a to the power of n is equal to a to the power of m plus n. So, if the question is given like this, what we have to do? We have to compare the given exponents and we should find that whether the bases are same or not. Here in these two cases, the base is 2, they are common, and but the exponents are different. So, therefore, what we have to do, if the bases are same means we have to use this, the law of exponent. When you are going to apply this law of exponent, we will give 2 to the power of 3 plus 5. So, according to this law of exponent, we have to write the base as it is and we have to add the exponents, that is 3 plus 5. What is 3 plus 5 gives us? 8. Very good. Now, let us learn one more example of the same kind. Using the law of exponent, simplify 3 to the power of 4 into 3 to the power of 5. So, in these examples, the bases are same, that is 3 is the base, and exponents are different, that is 4 and 5 are there. So, what we have to do here, according to this law of exponent, so we have to write the base as it is and we have to add the exponent 4 and 3. So, what is 4 and 5 gives us? Yes, 4 and 5 gives us 9. So, that is the simplified answer of 3 to the power of 4 into 3 to the power of 5 is 3 to the power of 9. Let us solve another example by using the law of exponent. So, that is p cubed into p squared. So, here also we have to simplify this example by using law of exponent. So, we have already learnt about the law of exponent, that is a to the power of m into a to the power of n is equal to a to the power of m plus n we have to use here. So, in this case the bases are in the both the cases is p and exponents are 3 and 2. So, according to the law we have to write the base as same, that is p, then we have to add the exponent, that is 3 plus 2 which gives us 5. So, therefore, the simplified form of p cube into p square is p to the power of 5. What we have to do to simplify the given exponents having same base? So, we have to write the product as it is and we have to apply the a to the power of m into a to the power of n is equal to a to the power of m plus n. So, for that since the bases are same, we have to write the base as it is, but we have to add the exponents 3 and 2. So, that is 3 plus 2 gives us 5. So, that is the simplest form of the p cubed and p squared. What about for 4 cubed and 4 squared? So, here also we have to simplify. It is easy. I hope you are all doing it. So, here what you are doing? Yes, write the base as it is, that is 4 is the base in the two cases. Write the base and add the exponents. So, which are the exponents over here? 3 and 2 are the exponents, add them, what you will get? Yes, you will get 5. So, therefore, the simplified form of 4 cubed into 4 squared is 4 to the power of 5. So, I am giving you one more example for you. You have to find the product of a cubed into a to the power of 5. Here, which is the base? You are right, a is the base. What about the powers of the two exponents? 3 and 5. What you have to do? Yes, you have to write a cube into a to the power of 5 as it is, which is equal to a to the power of 3 plus 5, which gives us a to the power of 8. Is it understood? I hope you are all following the law which has to be applied to simplify the exponential forms, or which is going to be used to simplify the exponents having the same base. I am giving you one more example, m to the power of 4 into m to the power of 7. Write m to the power of 4 into m to the power of 7 as it is, which is equal to add the exponents, that is 4 plus 7, which gives you 11. So, therefore, the simplified form of m to the power of 4 into m to the power of 7 is 11. I hope this formula help you people to simplify the exponents having same base. What about if the product of 3 exponents having same base, that is a to the power of m into a to the power of n into a to the power of p. Here you can see the product of 2 exponents. Here you are seeing the product of 3 exponents with the different powers, that is m into n into p. So, which is equal to, if there are m and n are exponents, then the answer will be equal to a to the power of m plus n. If the exponents are m and n and p, therefore, the answer will be equal to a to the power of m plus n plus p. What about a to the power of m into a to the power of n into a to the power of p? Yes, which is equal to a to the power of m plus n plus p. Okay, let us learn the law a to the power of m into a to the power of n into a to the power of p, which is equal to a to the power of m plus n plus p. Throw some examples. So, simplify a square into a cube into a to the power of 4. Here, which formula you have to use? You have to use the second formula. So, for that, what you have to do? Write a square into a cube into a to the power of as it is, which is equal to, simply add the exponents, that is 2, 3, 4 are the exponents. If you are going to find the sum of the exponent, which gives us the simplified form of a square into a cube into a to the power of 4. That is, a to the power of 9 is the simplest form of the given question. I am repeating again, how to simplify the a square into a cube into a to the power of 4. So, we have to write the product as it is, and we have to apply the formula of the product of 3 exponents having same base with a different exponent. So, when we are going to apply the formula, so we gives us a to the power of 2 plus 3 plus 4, which is equal to a to the power of 9. Let us take another example. Simplify 2 cube into 2 cube into 2 to the power of 4. Here also there are 3 exponents having same base with different exponents. What we have to do here? So, here also we have to write the base as it is, and we have to find the sum of the exponents. So, here which is the sum of the exponent? 3 plus 4 are the sum of the exponents. What about 3 plus 3 plus 4? What is the sum of 3 plus 3 plus 4? Yes, you are exactly correct. It is 2 to the power of 10. So, therefore, the simplified form of 2 cubed into 2 cubed into 2 to the power of 4, which is equal to 2 to the power of 10. Solve one more example. Simplify 3 squared 3 to the power of 4 into 3 to the power of 8. What about the product of these 3 exponents? Yes, the product of these 3 exponents, which is equal to 3 to the power of 2 plus 4 plus 8. Simply add the exponent. 2 plus 4 is 6 and 6 plus 8 is 14. So, therefore, the answer is 3 to the power of 14. The product of these 3 exponents, which is equal to the 3 to the power of 14. Now, let us learn the dividing powers with the same base. Dividing power with same base. So, when we are going to divide the 2 exponent having same base means what we will get? Let us test. 3 to the power of 7 divided by 3 to the power of 4, when we are going to expand it, we will get. So, how many times 3 is repeated here? 7 times 3 is repeated. So, write 3 into 3 into 3 into 3, that is 7 times, and 3 to the power of 4 can be written as 3 into 3 into 3 into 3. So, in case of numerator and denominator, the same numbers are there, that is 3, the product of 3 is there, in denominator also product of 3 is there. So, you can cancel this 4 repetitions of the 3 with the repetitions of the 3 4 times in the numerator. So, therefore, these 4 products of the 3 will going to get cancelled. Then reminders are remaining the product of 3 are 3 into 3 into 3. So, which is equal to 3 cubed. So, when we are going to simplify by expanding the exponents, we will get 3 cubed, which is equal to 3 to the power of 7 minus 4. The difference of the exponents in the numerator and the denominator, which is equivalent to or which is equal to 3 cubed. So, how to simplify the exponent? So, just by expanding the exponential value in the numerator and denominator. So, cancel the equivalent numbers in the numerator and denominator, you will get some product of 3, that is 3 into 3 into 3 in this case, that is that can be written as 3 cubed. So, this 3 cubed, which is equal to the difference of the exponents in the numerator and denominator. Let us try with one more example. 5 to the power of 6 divided by 5 squared. So, in this case, in the numerator 5 is multiplied 6 times, in the denominator 5 is multiplied 2 times. So, write 5 into 5 into 5 into 5 into 5 like this 6 times, and 5 square can be written as 5 into 5. So, this 5 into 5, here 5 into 5 is going to be cancel each other. The remaining numbers are 5 into 5 into 5 into 5. So, 5 to the power of 4 is going to be left behind. So, this 5 to the power of 4, which is equal to the difference of this 6 and 2, the difference of the exponents in the numerator and denominator. So, from these two examples, what is the conclusion we can draw means, if there is a exponent a to the power of m divided by a to the power of n, that can be written as a to the power of m minus 1. If there is a division form of the exponent having the same base, then the final answer we will get is equal to a to the power of m minus n. So, this is also one of the law of exponent, that is a to the power of m divided by a to the power of n, which is equal to a to the power of m minus 1. Let us learn about this law by solving few problems. Let us take 10 to the power of 8 divided by 10 to the power of 3. So, in these two cases, the bases are same, that is 10 is the base. Therefore, what we have to do? We have to find the difference of the exponents. What is the difference of the exponent? It is 8 minus 3. The difference is 8 minus 3, which is equal to 10 to the power of 5. Can you tell me what about 7 to the power of 9 divided by 7 to the power of 6? What will be the answer? What should I write in the box which is appeared on the screen in red color? Yes, you are right. The difference of 9 and 6 is 3. Therefore, the answer obtained is 7 cubed. Can you tell me about a to the power of 8 divided by a to the power of 5? So, what about the base in this case? A is the base. Then how to find the final answer? What will be the difference between 8 and 5? Yes, you are right. It is also a cubed. The difference of 8 and 5 is 3. 8 minus 5 gives us 3. Therefore, a to the power of 8 divided by a to the power of 5, which is equal to a cubed. Now, let us learn the one more type of examples under the title numbers with exponent 0. What happens if the numbers with exponent 0 means? To understand this, let us go with an example. What is the value of 5 cubed divided by 5 cubed? Let us find the answer. 5 cubed divided by 5 cubed, which is equal to, so in the numerator 5 is repeated 3 times, that is 5 into 5 into 5 we have to write. In the denominator also 5 is repeated 3 times, therefore, which gives us 5 into 5 into 5. So, both numerator and denominator having same quantity, we can cancel them. The final answer obtained is 1. Therefore, 5 cubed divided by 5 cubed is equal to 1. Take one more example, 3 to the power of 5 divided by 3 to the power of 5. In this case also, we can apply the formula a to the power of m divided by a to the power of n, which is equal to a to the power of m minus n. What is the difference of the powers? What is the difference of the exponents? 5 minus 5 will be 0. Then what you will get? 3 to the power of 0. Then 3 to the power of 0 is equal to 1. How can we come to the conclusion? So, we already solved that 5 cubed divided by 5 cubed is equal to 1. So, therefore, in case of left hand side we will obtain 1. In case of right hand side 3 to the power of 0 we will get. So, therefore, that 3 to the power of 0 is equal to 1. So, we can come to the conclusion that any number to the power of 0 will always gives us 1. Repeat again, any number to the power of 0 is always gives us 1. So, for a in this case is any non-zero integer. Here a represent non-zero integer, so that we can come to the conclusion that, or we can say that any number except 0 raised to the power of or exponent is 0 is equal to 1. That means, any number except 0 raised to the power of 0 is always 1. What about a to the power of 0? It is 1. Can you tell me 10 to the power of 0, which is also equal to 1? What about 25 to the power of 0, which is also is equal to 1? What about 100 to the power of 0, which is also is equal to 1? So, what is the conclusion you can draw? Except 0, any number to the power of 0 is equal to 1 always. My dear students, remember these things. We have learnt about the laws of exponent, that is a to the power of m into a to the power of n is equal to a to the power of m plus n when the bases are same. There is another law when the bases are same, that is e to the power of m into a to the power of n into a to the power of p, the product of three exponents having same base, which is equal to the a to the power of sum of the exponents, that is a to the power of m plus n plus p. And also you have learnt about a to the power of m divided by a to the power of n is equal to a to the power of m minus 1. So, this is another law you have learnt, and also you come to the conclusion that after solving few problems, a to the power of 0 is equal to 1 or any number to the power of 0 or any number with exponent 0 is equal to 1. These are the important topics of today's session. Based on that today's session, I am giving you some questions for the home assignment. Solve the problem and show to your teachers. Simplify and write in exponential form 2 to the power of 5 into 2 cubed. The second question is p cubed into p squared. The third question is 4 cubed into 4 squared, and the fourth question is a cubed into a squared into a to the power of 7. You have to simplify these problems and you have to get the answer and you should show to your teachers. I hope you have all learned today's concept effectively. You have understood all the concepts of the today's session. Let us meet in the next session with few more examples, with a few more exponential laws. Till then, have a nice time, keep learning, stay safe. Thank you all so much.